Coordinate geometry 1. Equation of a straight line. The equation of a line given by y equals ms. Let's prove it. So here, one of our points will start from the origin. That's 0, 0. So let's draw our line, our y-axis and s-axis. That's our point. That's our s and y. We know our gradient is y minus y1 out of s minus s1. And our point here start from the origin. Our gradient will be this. And then our gradient will be y out of s. Let's make the y the subject. Therefore, our y is ms. That's the equation of a straight line where the point starts from the origin. Now, if the point starts from anywhere, so the equation of a line passes through points. There are 2 points, s1, y1, s2, y2. These are gradients, like the way we did it. Therefore, this is our equation of a line. Y2 minus y1 is gradient times the difference between the s. Division of a line segment. We are still on a straight line. A line segment may be divided into a given ratio either internally or externally. So, to divide a line segment in a ratio m and n internal, this is our straight line. So we have the coordinates a and b. Then we locate a point between line AB. So our point is SP, YP. Then our ratio here is M and N. This is our ratio. So we will multiply the M by the B and the N by the A. Then we will divide it by M plus N for internal. So our P, SP, YP is mapped to P, M times the B plus N times the A out of M plus N. That's what I said. And we know that our B is S2, Y2, and our A is S1, Y1. So for internally, we are saying that M times S2 plus N times S1 divided by the ratio M plus N. Then M times y2 plus n times y1 divided by m plus n. This is for internal. With external, our line would then increase. Then our new point here will be Q. So our new m and n. So this one we will subtract since the line increase. So for our Q is m times s2 minus n times s1 out of m minus n, where our m is the ratio. M times y2 minus y1 out of m minus n, where our m is still the ratio. Let's solve example. Let's solve some example on division of a line segment. Like I said, we are still on a straight line. Subscribe to Sinaperos, my YouTube channel, for more videos. Find the coordinates of the point which divide the line joining point A and B in the ratio 3:2. A internally, B externally. So we start with the internally. Solution. For the internal, this is our formula as we proved over there, we stated over there. Now we know that our ratio is 3:2. That's our m and n. So our m here is 3 and our n here is 2. Then we have our points A and B. So we indicate our S1, Y1, and co. Then we substitute. Good. If we substitute, this is what we get. Our M is 3, S2 is 7, and so on. Then you simplify. This is our final answer. So for the coordinate of the points that divides the line is 27 out of 5, 14 out of 5. For externally, this is the formula. As for externally, you will just subtract, you will not add them. So here, we know our ratio and our points, then we substitute. Therefore, our final answer for externally is 15 out of 1, 22 out of 1. So the answer is 15, 22. Subscribe to Snappers, my YouTube channel, for more videos. We are continuing with the midpoint. And with midpoint, we are saying P, SP, YP of a line segment is the half, the sum of corresponding coordinates of the point. So let's do our axis and indicate it. Then here's our line. So we have A and B. Good. And we are saying this one is half the sum of the corresponding coordinates. So half the sum of the corresponding coordinates. So half of it. So it will be half of S1 plus S2, comma half of Y1 plus Y2. So these are our points. So it's half of it. So this is it. Half of the sum of corresponding coordinates of the points. So these are formula for the midpoint. So let's solve some example. If you know our S1, S2, Y1, Y2, we can do the substitution. So here, our A, we have 3, -2, B, 5, 7, 6. So let's substitute. So the 3 is S1 and the 7 is our S2. Good. Then let's simplify it. Then our final answer of the point is 5, 4. 5, 4. That's our point. Point of intersection. When two straight lines meet, they intersect at one point. So if two lines intersect, the coordinates of the point of intersection must satisfy both equations. Hence, the coordinates of the point of intersection can be obtained by solving two equations simultaneously. So this is our first line, that's L1, and our second line, that's L2, and the point of intersection is P, S, Y, and this must satisfy the two equations. So let's solve some example. Find the point of intersection of the two lines. Solution. Our first one will be our equation 1, and then our second one will be equation 2. Then we solve it simultaneously. I'll use the elimination method here. So I'll subtract equation 1 minus equation 2. Then the y will goes. So therefore our s is 2, and therefore our y is -4. Our point of intersection is 2 and -4. Hence, this must satisfy the two equations. That's the point of our intersection. Coordinate geometry 1 on a straight line, parallel and perpendicular line. Two lines are said to be parallel if they have the same or equal gradient. So this is our first line, our second line. So if the gradient of the first line is the same as the second line, then they are parallel. So the first line, we have determined the gradient of a line in our previous lesson. And know that the gradient is tan theta. So here to the gradient will be tan theta. So they are parallel. Perpendicular. Two lines are said to be perpendicular if the product of their gradient is -1. So here the product of their gradient is -1, then this is said to be perpendicular. So the product of this gradient is -1. Let's solve some example on parallel and perpendicular line. Determine the equation of a line passing through the point P, 2, 5. And the line is 2x minus y minus 8 equals 0. A, parallel. Solution. And our line here is 2x minus y minus 8 equals 0. And we all know that the equation of a line is in the form y equals ms plus c, where m is our gradient. So you will turn the equation, this equation 2x minus y minus 8 into the form y equals ms plus c. So our y is 2s minus 8. Then we compare. Therefore, our m, that's our gradient of the parallel line, is 2. Then we will find the equation of the line. And we know the equation of a line is y minus y1 equals m times the difference of what? S. And we know our point. So our point is 2, 5. Our S1 is 2, Y1 is 5. So this is our equation of a line with parallel line. Now let's move to the perpendicular. The same thing. After the perpendicular, we know that that one is the product of the gradient equals -1. So if you find the gradient, it will be -1 out of m. And here our gradient was 2. So the negative reciprocal of this is -1 out of 2 for perpendicular. Then we substitute. So this our point is our y1 is 5, s1 is 2.